Welcome to the Explainer. You know that feeling when you snatch your hand away from a hot stove, like before you even really feel the pain? Or how a certain smell can just instantly throw you back to being a kid? Well, the answer to all of that is hiding in the most complex, high-speed network you own, your body's electrical grid. So today, we're going to plug in and explore the absolutely fascinating world of your nervous system.
To really get a handle on just how powerful this thing is, let's start with a quick question. What do you think is faster? A Formula One car going full tilt? Or the signals firing around in your body right now?
Yep, if you guessed your nervous system, you are 100% correct. It's not even a contest. Nerve impulses can literally rocket through your body at over 250 miles per hour, leaving the fastest cars on the planet in the dust. This thing isn't just a network. It's a biological superhighway. It's the electrical grid that powers every single thing you think, feel, and do. So how in the world does it manage such a massive job? Well, it all comes down to this really simple but kinda beautiful three-step dance that's happening all the time. First, it sucks in information from the world around you. That's your sensory input. Next, it figures out what it all means. That's integration. And finally, it decides what to do and sends out the orders. That's your motor output. So it's basically sense, think, and act. That cycle is the invisible engine running your entire life.
Okay, to really get the scale of this whole operation, we need to look at the blueprint. I want you to imagine a giant map, maybe of an empire, and it's split into two big connected territories. That's pretty much the basic structure of your nervous system.
So on one side of our map, you've got the central nervous system. That's your brain and your spinal cord. Just think of this as mission control, right? The secure command center where all the big decisions get made. And then, spreading out from there, you have the peripheral nervous system. These are your field agents, a huge network of nerves all over your body, constantly out there gathering intelligence and carrying out orders from the top.
Okay, so we've got the big picture. Now, let's zoom in. Way in. We're going to go from this massive network down to the microscopic level to meet the individual messengers that actually make this whole thing work.
So meet the neuron. This is the star of our show today. It's the basic building block of everything, a tiny biological marvel designed for one thing and one thing only: communication at incredible speeds. Every thought you've ever had, every feeling you've ever felt, it's all thanks to trillions of these little guys working together.
And the absolute genius of the neuron is its design. It's so efficient. See, an impulse, which is really just an electrical message, it always, and I mean always, travels in one direction. It's like a one-way street for information. A message comes in through the dendrites, gets processed, and then zips down the axon to the next neuron. This one-way flow is absolutely crucial. It's how your body makes sure a signal to, say, wiggle your toe doesn't get mixed up and make you blink instead.
But here's where it gets really wild. For all this talk about a network, these neurons, they never actually touch. There's this tiny microscopic gap between the end of one and the beginning of the next, and this little space is called a synapse. So if they don't touch, how does the message get across? Well, this is the really cool part. It's like a high-stakes relay race. When the electrical signal hits the end of the line, it triggers the release of these special chemicals. These chemicals then shoot across that tiny gap, the synapse, and they ignite a brand new electrical signal in the next neuron. The baton is passed, and the message keeps moving at that insane speed. Okay, let's zoom back out from that tiny little gap and go back to our network of field agents, the peripheral nervous system. Because this is where we see a really fascinating split in who's in charge. It turns out you're not consciously controlling all the signals flying around in there. The system kind of has a split personality. So on one hand, you have the somatic system. This is your conscious control panel. When you decide to kick a ball or type a message, that's your somatic system carrying out your direct orders. But then there's the other side, the autonomic system. This is the silent autopilot running everything in the background. It's what keeps your heart beating, your lungs breathing, your food digesting, all without you ever having to think about it. It is the ultimate multitasker, and it's literally what's keeping you alive right now. So when you put all of this together, you got mission control, you got the field agents, the one-way signals, the chemical leap. What do you actually get? You get a system that does way more than just move your body around. This whole incredible electrical network is what builds your entire reality. And to see how, we've got to look at how it gets its information in the first place, through your senses.
Let's make this real. We're going to follow a single piece of information all the way from the outside world into your brain. So just for a second, imagine the smell of your absolute favorite food. Maybe it's pizza, maybe it's fresh-baked cookies. What is actually happening to create that experience?
It's this amazing four-step journey. First, these tiny molecules from the food float into your nose. They get caught by special cells, and that's the trigger. An electrical impulse gets fired off, zipping straight to your brain. And only then, when your brain decodes that signal, do you get that rich experience of smell. Think about that. In a split second, a physical particle from the air has been turned into a memory or an emotion, all inside your head.
And what's really cool is that this same basic process, this translation, it applies to your other senses too. Let's take taste. It's a remarkably similar story, just using slightly different equipment.
So, this time your saliva dissolves the food and that chemical solution washes over thousands of taste buds. Those taste buds are like little sensors, each firing off their own signals to the brain. The brain then deciphers this code and tells you, hey, that's sweet, or whoa, that's sour. It's another perfect example of your body acting as a chemical translator, turning stuff from the outside world into an experience. But your nervous system isn't just a master chemist, it's also an incredible physicist. It can take pure physical vibrations in the air and turn them into the entire world of sound.
I mean, this is just a beautiful piece of biological engineering. Your ear funnels in sound waves, making your eardrum vibrate. Those vibrations get amplified by 3 of the tiniest bones in your entire body. Then, that shaking stimulates thousands of little hair cells deep in your inner ear. And here it is, this is the magic moment. Those cells turn that physical shaking into a pure electrical signal, the only language your brain speaks. And only then do you perceive it as sound.
So you see, it all comes down to having specialized translators for the job. For taste and smell, you've got chemoreceptors that detect chemicals. For vision, photoreceptors that detect light. And for hearing and balance, mechanoreceptors that detect physical vibrations. Each one is a specialist, a unique door to the outside world, but they all have the exact same job. Convert whatever they sense into the one language your nervous system gets, the electrical impulse.
And this really brings us all the way back to the main point. Like Dr. Kanta says here, your mission control, your central nervous system, is constantly summing up all this input. Every single thing you experience, every sight, every sound, every feeling, is nothing more than your brain's final interpretation of millions and millions of these electrical signals. Your entire reality is an electrochemical masterpiece.
And that leaves us with one last, kind of mind-bending thought to chew on. If this incredibly complex system is what creates your world, that also means it defines the limits of your world. It's built to see a certain range of light and hear a certain range of vibrations. So the ultimate question isn't just about what you perceive, but what are you not perceiving? What else is out there right now that our biological hardware just isn't built to translate into our reality?